Okay, so this is the key to section 7.1 part A. In the first few problems, you wanted to state the domain of each rational function and then state the domain in set notation. All right, and so you really need to see the videos that go with this. But whenever you want to find the domain of a rational expression, what you want to do is look for the restrictions. So you're looking for restrictions. All right, so the idea of restrictions. So in other words, since we're dealing with a fraction, a rational expression, remember your denominator cannot be 0. So what you want to do is find out where are these denominators equal to 0. So wherever those denominators are equal to 0, those are your restrictions, and then those cannot be in your domain. So every other number would be in your domain except those restrictions. So for example, if you look at the first one, my denominator is x minus 2. So the question is, what value of x will make this denominator equal to 0? So when is this denominator equal to 0? Well, the denominator is equal to 0. Remember, you're solving a linear equation, so you add 2 to both sides. The denominator is equal to 0 when x is 2. So your restriction for this one is that x, let me put it right here, so x cannot equal 2. So every other number can be in your domain except 2. For example, if you choose 3, 3 minus 2 is 1, and so f of 3 then would be 5 over 1. So the idea is this. I'll just kind of do it here. So remember, the domain is your set of x values. All right, so any number that you can plug into x and you get a y value back, then that x is in your domain. So for example, in the first one, where we had f of x equal 5 over x minus 2, if I let f be, let's say, 3, so remember x is 3, so 3, let's see if when I plug in 3, I get a y value back. Remember, f of x, remember, is the same idea as y. So when I plug in 3, I get 5 over 3 minus 2, which is 5 over 1, which is 5. So I get a y value back. I get a real number. So this is a real number. So 3 is in the domain. If you plug in, let's say, negative 2 in the domain, for x rather, I get 5 divided by negative 2 subtract 2, which is 5 divided by negative 4. So this is also a real number. So no matter what I plug into x, I'm going to get a real number except when x is 2. Because when x is 2, if I find out what f of 2 is, I get 5 divided by, and wherever we see an x, you plug in 2. So I get 2 minus 2, which is 5 divided by 0, which is undefined. So 2 is the only value for x which I cannot use. Because when I plug in 2 for x, I get something that's undefined. Okay, so my domain would be every other real number. Every other real number. I can use decimals, negative 3.8, negative 4.67. I can use fractions. I can use square roots, cube roots, fourth roots, anything like that. Any real number except 2. Because 2 makes my denominator 0, and you can never divide by 0. So that's the idea you're going to use in these first few problems. So you're going to find out where is the denominator 0. Wherever it's 0, that's the one you cannot use. You can use every other number except this. Okay, so here's how you're going to write a set notation though. So you're going to say the set, so you can use braces like this. So you're going to say the set of x's such that x is a real number and, that's an and, x cannot equal 2. That's how you write it. And then close your brace. That's brace here. All right, so the set, so the brace is a set of x's such that, this symbol means such that, x is a real number and x cannot equal 2. That's your restriction. Okay? All right, let's look at the next one. So again, all you do to find the domain of a rational expression is find out what makes the denominator 0. Not the numerator, but the denominator. What makes 0? Because you can never divide by 0. You can have 0 in the numerator. For remember, 0 over 7 is 0. But you can't have 0 in the denominator, so 8 over 0 is undefined. Okay? Alright, so over here, so you take the denominator, all you do is take the denominator and set it equal to 0, and notice this is a linear equation. So to get the variable t by itself, you're going to divide both sides by 2, and I get t equal 0. So my restriction is that t cannot equal 0. So I can use any number but 0 for t. So you say the set of t's such that t is a real number and t cannot equal 0. Okay, the next one, you find out where is the denominator equals 0, so 2x plus 1 equals 0. So if 2x plus 1 equals 0, then that means 2x equals a negative 1. And if I divide both sides by 2, that means that x is a negative 1/2. So when x is negative 1/2, my denominator is 0. You can check it. 2 times a negative 1/2 is a negative 1. Negative 1 plus 1 is 0. So I found the restriction. So here, x cannot equal a negative 1/2. So therefore, my domain will be any other number but that. So you say the set of x's such that x is a real number and x cannot equal negative 1/2. Okay, the next one, x squared minus 25. Okay, so I'm going to go ahead and do that here. X squared minus 25 equals 0. Now notice in all the other problems, those were linear equations. Here, this is quadratic. So you got to remember from section 6.6 or section 6.6 how to solve this quadratic equation. So it is in standard form. Remember, you got to have 0 over here, and you're going to end up using the 0 factor property. And so this is the difference of two squares, and so I get x minus 5 times x plus 5 is equal to 0. And remember, the 0 factor property says that if you have two or more factors whose product is 0, then that means that definitely one of them has to be 0. So either x minus 5 is equal to 0, or x plus 5 is equal to 0. And notice I went from a quadratic equation to two linear. And so here x equals 5, x equals negative 5. And so 5 will make this denominator 0 because 5 squared is 25. 25 minus 25 is 0. Negative 5 makes this denominator 0 as well because when I square negative 5, remember that means negative 5 times negative 5, which is a positive 25. 25 minus 25 is 0. So I found the restrictions x cannot equal 5 and a negative 5. So then your domain in set notation, you'll say the set of x's such that x is a real number and x cannot equal 5 or a negative 5. All right, and then over here, again, you set that denominator equals 0, so t squared minus 5t equals 0. So find out what t makes this denominator 0. Now notice this is quadratic. This is a quadratic equation. It is in standard form. So you're going to factor. I can factor out a t. So I get t times t minus 5 equals 0. And then I set each of these factors equal to 0. So I say t equals 0. So I found one of them. T is already by itself. And I set the other one equal to 0. So t equal 5. So that means that my restriction is that t cannot equal 0 or 5. So my domain then would be the set of t's such that t is a real number and t cannot equal 0 or 5. All right. Okay, now the next part is where you're going to simplify each rational expression. So remember the first step is to factor the numerators and factor the denominators. So the numerator I can't factor. The denominator I can because that's the difference of two squares. So when I factor this, I get x minus 2 divided by x minus 2 times x plus 2. So once you factor, the next step is to reduce your common factors if you have any. And don't forget, we did talk about opposites, so look for opposite factors as well. All right, well, if you look at this, this factor x minus 2 reduces with this factor x minus 2. Now remember, when you cross them out like we did here, don't forget what that means. That means that first of all, x minus 2 divided by x minus 2 is 1, which means that when I divide those out, I end up with factors of 1. And so I get 1 divided by, and then 1 times x plus 2 is x plus 2. I get 1 divided by x plus 2. All right, number 7. Okay, so again, you're going to factor first. Now, remember, let me just mention this. Some students get a little confused. You see where you have that x squared and the x squared? They want to cancel these out. You can't, because x squared is not a factor. Remember, factors are separated by products. So x squared is not a factor. If you had this, if you had x squared times 9, then x squared is now a factor. And so, because of that product, you have x squared times 9. But the fact that you have x squared minus 9, x squared's not a factor. Okay? Now, okay, so what you're going to do is you're going to factor the numerator, so that's the difference of two squares. So I get x minus 3 times x plus 3. The denominator, that's a trinomial, and I can factor that. I'm going to get x plus 3 times x plus 3. So that's how you factor that one. And remember, you can always check yourself. You should always check yourself if you have time just by foiling this out, seeing if you get this back. All right, and then you reduce. So my first factor is x minus 3. I don't have any in the denominator. My next factor is an x plus 3. I have 2, but I can only reduce 1. And don't forget, you're left with factors of 1 in their place. And so x minus 3 times 1 is x minus 3. 1 times x plus 3 is x plus 3. And so there's your answer. X minus 3 divided by x plus 3. Okay, now the next one, I can factor the numerator. I can factor out a 5v. So I get 5v times v minus 1 divided by 1 minus v. All right, now, if you look at these, your factors are 5, v, and v minus 1, and 1 minus v. So I can't reduce the 5s, I can't reduce the v's, and if you think about it, you have v minus 1. There's no factor down there that's exactly v minus 1, but you have to notice this. You have to notice that v minus 1 and 1 minus v are opposites. So you always need to look for that. So remember, the opposite of, let's say the opposite of 6 is negative 6. All right, so that's what we mean by opposite. So the opposite of 6 is negative 6. So the opposite of v minus 1, all you do is take the opposite of each term. So the opposite of a positive v is a negative v, which is what this is, and the opposite of a negative 1 is a positive 1, which is what this is. So those are opposites. So that means this. Remember, we talked about opposites in the previous section. So that means that if I reduce these, see, these are opposites, then that's a 1 and that's a negative 1. So when I reduce opposites, one factor ends up being a 1 and the other factor ends up being a negative 1. It does not matter which one's a negative 1, which one's a positive 1 in the end. But when you reduce them, one's factor is a positive 1, the other factor is a negative 1. And remember, when you divide numbers that are opposites of each other, you get negative 1. All right, so these are opposites. So what I'm going to do is I'm going to divide these out just like this. One's a positive 1, the other one's a negative 1. And now we just multiply out. 5 times v times negative 1 is a negative 5v over 1, which is a negative 5v. So that goes here. Okay, the next one. I can factor the denominator. I can't do much with the numerator for right now. So that's 2 minus x divided by, all right, in the denominator, I'm going to get x plus 6, x minus 2. So that's what I end up getting. All right, now again, you have to recognize that 2 minus x and x minus 2 are opposites. 2 minus x and x minus 2 are opposites. So always check. The opposite of 2 is a negative 2. The opposite of a negative x is a positive x. So those are opposites. So that means that when I cross them out like this, when I reduce, one's a positive 1 and the other one's a negative 1. And we tend to, not always, but in many situations, it's easier to put the factor that's in the numerator, the negative 1, and the factor that's in the denominator, the positive 1. And so now you get this. You get a negative 1 in the numerator, and then x plus 6 times 1 is x plus 6. And so there's your answer. Negative 1 divided by x plus 6. Now another way of writing this, by the way, is to, if you remember this from a previous course, if you had, let's say, negative 2/3, then remember that also means the same thing as 2 over negative 3, which means the same thing as negative 2/3 like this. So the opposite of 2/3 is a negative 2/3. All right, so basically, this negative symbol, you can just put it like this, and it'll be the same thing. Okay? All right, and then finally, number 10, you have, when you factor this, you're going to end up with, let's see, x, so 5 and 2. So 5, 2, subtraction, addition. And always check yourself. When you follow this out, you will get this back. In the denominator, let's see what we get. X, that will be 4 and 2. So x plus 4, x plus 2. All right, so we factored both numerator and denominator. And now let's reduce. The only ones I can reduce are these. And remember, when you reduce them, you're left with factors of 1 in their place. So we have x minus 5 times 1 is x minus 5. X plus 4 times 1 is x plus 4. And there's your answer. X minus 5 divided by x plus 4. Okay, so that's going to take care of this key.